Okay, so today is 7.4 special triangles. So a big part of this unit is you learning what the unit circle is. And in order for you to have like a good understanding of the unit circle, you need to know all these little parts. And that's kind of what the buildup of this unit is, okay? And so one of these little parts is related to what we call special triangles, okay? So we have two special triangles where the ratios of the sides are important. And this is actually this actually comes up on the SAT and stuff. So it's good to know in that sense, okay? So one of the special triangles is what we call a 45 90 right triangle, okay? So this is a triangle that looks kind of like this. So the legs are actually the same length, and then you have your hypotenuse, okay? So that's the 90 degrees, and then these are 45 degrees. Now, since these two angles are both 45 degrees, we know that the legs are actually the same length, okay? So if I called this side X, this side would also be called X. And so what we can actually do is we can figure out what is the pattern between the legs and the hypotenuse, right? And we're gonna do that by using Pythagorean theorem, okay? So this is a little bit confusing, conceptually. So if any part is not making sense, let us know. But I'm gonna use Pythagorean theorem to find what the hypotenuse is in terms of X. So remember, the Pythagorean theorem is a squared plus b squared equals c squared, where c is always your hypotenuse, and then a and b don't really matter as long as you get c correctly. Okay, so my a is x squared, so I have x squared plus x squared equals c squared. Now these are obviously like terms, so I can combine these and write it as 2x squared equals c squared. Now, I'm trying to find what c is. So to get rid of the squared, I'm going to square root both sides, okay? So I'm going to get c equals the square root of 2x squared. But I can actually simplify this to c equals x square root of 2, because I know the square root of x squared is just x, right? So I just simplified it a little bit further. Okay, so I now know that in terms of x, c is x square root of 2. Okay, so now I know that there is this relationship. If a side is x in a 45, 45, 90 triangle, then the hypotenuse is x square root of 2. And we're going to come back to this in a second. I'm going to now introduce the second special right triangle, okay? And the second one is what we call a 30, 60, 90 triangle. 30, 60, 90 triangle, okay? This one's a little bit more confusing, and when we draw out the triangle, I want you guys to write it actually pretty large because we're going to be annotating it, okay? So the triangle is going to look kind of like this, okay? This is 60 degrees, this is 30 degrees, and this is 90 degrees, okay? But what I'm actually going to do is I'm going to draw another 30, 60, 90 triangle reflected like this. And if you want to draw it in dotted, you can, or you can draw it in a solid line. And so this is 30 degrees, this is 60 degrees, and this is 90 degrees. So if you notice now, this whole triangle right here, I'm going to highlight it, is actually an equilateral triangle, meaning that if this side is x, so is this side, and so is this whole side, right? And if we know this bottom side is x, we know just this part right here is half of it. So I know that this is going to be half of x, right? The whole side is x, so half of it is going to be half of x. So again, I'm still focusing on, let me highlight what I'm focusing on. I'm now focusing on this green triangle right here, okay? I don't care about the dotted triangle. I'm just focusing on this green triangle, okay? And I want to figure out what this missing side length is right here, right? Because I don't know what this is. I know the hypotenuse is x, and I know the bottom is 1/2 x. So again, I'm going to use Pythagorean theorem, right? This is my C, I'll make this my A, and I'll make this missing side my B. So I have 1/2 x to the power of 2. I don't know what my B is, and I know my C is x squared, or C squared is x squared. Now, let me just simplify. So 1/2 to the power of 2 is 1/4. I'm going to have x squared plus b squared equals, I'm just going to put a 1 in front, 1x squared. I'm now going to subtract 1/4 x squared on both sides. So I'm going to get b squared equals, well, 1 minus 1/4 is just going to be 3/4 x squared. And then similarly, I'm going to square root both sides. So I'm going to get b equals the square root of 3/4 x squared. But I can simplify this a lot further, right? Obviously, square root of 3 stays a square root of 3, but the square root of x squared just becomes x. And actually, the square root of 4 becomes 2. So this missing side right here is x square root of 3 over 2. So just to make this cleaner, I'm going to just erase this like dotted part. If you want to redraw the triangle, you can. But we now know this about a 30, 60, 90 triangle. So if parts of this didn't quite make sense, that's totally okay. But what you need to have in your notes are like what we calculated. You need to have the triangles annotated. So now that we know these things about triangles, about these specific triangles, we can actually solve for missing sides, okay? So let's say, for example, I had a 45, 45, 90 triangle, 45, 45, 90 triangle. And let's say I'm given that the hypotenuse is 4. And I'm trying to find what these sides are, right? Obviously, whatever the sides are, they're going to be the same. So what I'm going to do is I'm going to set this 4 equal to the ratio that I know. I know that 4 is equal to x square root of 2. And now at this point, we are going to solve for x, right? So I want to get x by itself, so I need to divide both sides by square root of 2. So I'm going to get x equals 4 over square root of 2. Now here's the thing, we don't like square roots on the bottom. It's so annoying, but we have to do what's called rationalizing the denominator, which means whatever is under the square root on the bottom, we're going to multiply to the bottom and the top. So see how it's a square root of 2 on the bottom? We're going to multiply that on the top and bottom. So I'm going to get 4 square root of 2 over, well, if you put this in your calculator, you're actually just going to get 2. Okay? And then I can simplify this to 2 square root of 2. So I know that x equals 2 square root of 2, and I know these missing sides right here, this and this, are just x, right? So I know that both of these missing sides are going to be 2 square root of 2. So if the hypotenuse is 4, both of these missing side lengths are 2 square root of 2, okay? For a 30, 60, 90 triangle, it's like it's much easier, I think. So, oops, let's not do that. I'm going to draw in the angles. Okay, and so let's say I'm given that the hypotenuse again is 4, and I want to find what these missing sides are, okay? So let me label everything. So this is x square root of 3 over 2, and this is 1/2 x, right? So I immediately know that x is just equal to 4, right? Because that's what I wrote here, x equals 4. So it's actually pretty simple. I just have to plug in 4 in for all these x's right here. So I'm going to have, this is going to give me 4 square root of 3 over 2, which I can simplify to 2 square root of 3, right? Because 4 divided by 2 is 2. And then I can, again, simplify this. 1/2 times 4 equals 2. So I've now solved for the missing sides, okay? If this doesn't make sense, please ask for help. I know this can be tricky. This is one of the trickier lessons. Otherwise, move on to practice. You're going to be doing questions like the two that we just did, okay? So go ahead and move on.